Welcome to your Chapter 5 lab, Mineral Identification. In order to do this, you need to open up this link and this link, which I already have opened up for us here. The demonstration video you're watching goes in here. And if you need some extra help, here's a tutorial on YouTube and another one on YouTube, but this video can't be embedded, so just click on the link if you want. That's only if you run into trouble. The mineral identification table is part of your reference section in your textbook. You can get to it either by this link or by going back to the main page for Earth Science and clicking on the reference table. You will have to scroll down. When it opens up, it'll be on page 796. Scroll down past the topographic map stuff, past the periodic table, all the way to properties of some common elements. This lists, obviously not all 4,000 elements, but the rock-forming elements and a few other most common elements. By alphabet, it will list their approximate hardness. It will indicate the most common colors, but remember, as with quartz, things can change a lot. The streak, the color of a mineral's powder, how it breaks or cleavage. For example, chalcopyrite will break in one direction, but not very well. Copper, the metal, it doesn't break at all. Then any other weird remarks. Let's find a cool one. Here's one. Olivine comes in glassy luster. It's granular, and hard to pronounce, and it's greenish yellow. Very cool. So use this and this. This format for the lab is going to be the same format as used in the igneous rock lab, the sedimentary rock lab, and the metamorphic rock lab. So get used to this. You're going to be using it 4 times. For color, just list the color. For streak, the color of the mineral's powder. Luster, if it's metallic, write metallic. If it's non-metallic, record if it's glassy, pearly, or dull, if that's an option. Hardness, these are just for comparison. And everything else we're going to cover. You'll want to copy this table into your answer document and paste it there. Right now, we're going to do mineral number 5. When we choose the name of the mineral, we have to choose from this list and only the items with the asterisk. How do I know that? It's in the directions. But who reads directions? Okay, let's go to the lab. We're supposed to start with mineral number 5, so I'm going to click on it. If there's anything in here, I'm going to reset to make sure that all these fields are blank. This is how we're going to grade ourselves. This is the name, but let's go to the top. Ooh, weird. It's kind of a pink, peach color or something like that. Let's see if we can find another picture. Now I'm going to hit Command plus on the Mac, and that makes the image bigger. To make it go back to normal, Command minus. Interesting. Okay, let's do the hardness test. It's not a real hardness test. You don't have your fingernail. Well, you do have your fingernail. You're not going to use your fingernail, a copper penny, a steel file or nail, or a diamond, or a piece of glass. Why do I reference those? In a typical lab, you'll use your fingernail. Fingernail is about a hardness of 2.5 on Mohs scale. It's harder than a pencil, which is kind of interesting. You ever notice what's on the side of your pencil? There's a number 2 on it. That's from Mohs scale. The copper on the outside of a penny, or real copper, really is about 3.5. A nail, somewhere around 4.5 to 5, depending on the steel that's in there. It can get harder, especially if you're watching those QVC sword channels. And glass, oh, this is a little bit off. Glass should be around 6.5, but we can go with that. I'll have to change this. Okay, back to identifying this pink thing. It's harder than talc. It's harder than talc, gypsum, and calcite and your fingernail. It's not scratched by a hardness of 4. This is weird. Huh. Okay. Harder than a nail. It's now harder than glass. Weird. That's got to be... No. Whoa. It is scratched only by hardness of 10, which you probably know is a diamond. This isn't a diamond. So we know it has to be a little softer than a 10, but harder than a 9. What's the closest thing? I'm going to go for a 9. Let's see if it cleaves or fractures. It says it has 0 cleavage directions. That means if you break it, it won't split along a flat line like we see here in the picture. And it has uneven to conchoidal fracture. That means it breaks like a piece of glass with no particular direction. So, irregular fracture? No, conchoidal is what it said. And cleavage, it said it had 0. Streak test. This is what happens when you rub it on an unglazed porcelain plate or you somehow get the powder of this. We're not really doing it. It'll tell you that the powdered sample streak is white. Click white. Does it react with a magnet? No. So, never mind. It doesn't react with a magnet. Does it react with hydrochloric acid? If you put dilute hydrochloric acid on calcite, it will react. If you put it on dolomite, when dolomite is scratched, it will react. And this one doesn't react with hydrochloric acid, so we know it's not calcite and probably not dolomite. So don't click that. It didn't react. See if it has a taste. No. Okay. Now, I'd say it's kind of pink or peach colored. So color, pink. Its streak, if you remember, was white. Cleavage, what did it say, 0? Oh man, this is tough. Crystal form is difficult, so you know what? I'm just going to click that and see what happens. Oh, luster. Does it shine like a metal? Like the metal on your faucet in your sink? Or like a non-metal? This doesn't look like a metal at all. So let's say non-metallic. Using all this information, we can now go to your mineral identification key, this guy, and start going through here. The thing that stands out most is the hardness here. It has to be a 9. So let's go through this and sort them out. Here's a 7.5 to 8. It maybe could be that, but ooh, pink and colorless. 6-sided crystals. Wait, greenish color? Glassy luster? I don't know. That's kind of soft too. It's beryllium silicate, beryl. It can't be mica because that's way too soft. Corundum, Al2O3. Brown, pink, and blue, hardness of 9, white streak. It comes in barrel-shaped 6-sided crystals with flat ends. Sounds like our suspect. Let's keep going. Could be diamond, but probably not. What else is really resistant to scratching or hard? Olivine, it's a little too soft, and it has to be green glass granules. No. Topaz, varied color. It cleaves in one direction only. Has to be brilliant to glassy luster. Does this look like shiny glass? Not really. Not even the other image looks like glass. So it's probably not that. Tourmaline, black varies, triangular cross section, so it's probably not tourmaline. And that's the end of our minerals. So let's try this one, corundum. Everything is filled in. Let's grade it. Oh man, looks like we got everything but the crystal form. And they left a comment in there. Interesting programming. So let's change the crystal programming. Hexagon. Hexagon is like a stop sign. It has 6 sides. You slice this out, painted it red and white, put stop on here. This could be a stop sign. Let's try it again. Cool. We're good. You then are going to go back to your answer document. And if this were a real mineral that you were doing, you would put pink for the color. Streak was white. Luster was non-metallic. Hardness somewhere around 9. Fill in the data from this. And here I would put in 6-sided barrel-shaped crystal. And then put the name corundum, and you would get credit for this. There are 12 minerals you have to do. Notice that the numbers are a little weird. Again, these are going to change throughout the semester. Choose only the minerals that are in here. Don't go 1 through 20. Choose 1, 3, 4, and so forth. There's 1. Can you believe he's really going to do this? Yeah, because if I don't, well, that one's cool. People will get confused. Skip to 4. And again, if you have any questions, you can click on the other images. Well, that's it. I think you're good to go. And keep in mind, this is the same format that we will use for igneous, sedimentary, and metamorphic rock labs. Good luck!